Hello and welcome to the channel. In the past video, we talked about lazy column and how to inflate items into it. Now, in the last video, it was very basic example like how to inflate an item and create your own cell, then inflate it into the lazy column. Now we'll talk more about a few actions that a user can perform, like adding an item to the existing dataset or removing an existing item from the lazy column itself. Now, to make it more readable or more understandable and towards the daily use case sort of a solution, I won't be coding everything into this main activity. I would rather move this responsibility of getting the items and moving or passing these items towards the view to a view model, and that view model, because it's a life cycle aware thing, will just, as soon as the view model is initialized, what we will do, we will inflate a dummy set of items, then we will pass it on to the view and we will render based upon the state it received out of the view model. So for this video, I expect a very basic understanding of view model and how state flow or shared flow work. If that's something that you guys want to know more about, I can probably create a video about state flow and shared flow and their relationship between how they relate to and what they relate to in RX world, because I come from RX world, so it was very easy for me to pick on them. So moving ahead, I won't talk more about them. So this is a view model class that I created just now, and for now it does not have anything, which it's like an empty class. So first of all, I want to define my view state, what it can be in. So assuming, let's say that I have a data class which is like student list view state. So it's the list view and it's the view state variable which will hold the view state. And let's assume that we want to simulate a real world situation where a data will come from the server and you will show the loading indicator, and then you will, after the loading indicator, like after you have received the item, you will disable the loading indication and then you will inflate the items into the lazy column. Let's do something similar to that, and let's make a variable which will be boolean, which says if it's loading or not. If it's loading, then we'll show a loading indicator, and if it's not loading, then we'll just move ahead, and we'll have list of let's say students, list of students. So it's the same class that we created in the last video, in which we had a student class which had ID, name, level, and background color. Now let's move to view model again, and yeah, I think this will suffice. And let's say we also create a sealed class for view events, student view events. So this will be more or less like actions that a view will perform. So we will have a data class which add item, which will have student instance, and it will be a student list view event. So similarly, just copy duplicate the item by pressing command D and do remove item, and we'll pass the same student and we'll remove it from the list. So these are the two actions that our view can perform, and this is the representational state of the view. Now let's do one thing. Let's just on init, let's create, first of all, let's create a state flow, shared flow, mutable state flow basically. It will be UI state maybe, and let's make it private so that our view cannot directly modify it, so it becomes the single source from here. And it will be mutable state flow with initial values of student list view state, and let's define as true, because we want it to be always in loading state as soon as the view appears. and it will be an empty list. So now we have our UI state defined in. Let's create a read-only state as well, which will be consumed by our view, and it will be public property so that our view can access it. Let's make it a function basically, consumable state, and it will be UI state dot as state flow. Now state flow is an extension function which converts it to a read-only state flow. So the consumer of this particular view model and the state in question or in this specific scenario can only consume it and cannot modify the contents of the state, and the state can only be modified by the view model. Now let's say we also create a public method. It's a method, let's say handle event, handle view event, which will have this event class as an input. Well, view event, sorry, let's make it a function first. Now view event, and this is an event. Now let's do a when statement and handle all the branches. So we'll perform some action when add item is being called, and we will perform another action when remove item is being called. So this is like the very bare bones kind of a system for this particular view model. Now let's say that as soon as this view model is initialized, that means our onCreate has been called from the activity itself. What we want to do is we want to fetch dummy data. Now let's say that this is my function, which is a private function. Maybe just rename it to fetch student list data. Now we want to like simulate a real world system where let's also add one error state as well. Let's add an error message, and it will be a type of string, and it is nullable. So if it's null, then we don't have any error, and if it has some content, then we will mark it as that the view or the view state is an error state, and will show a respective error message based upon that particular state. Now when we have this function fetch student list, let's add a let's do view model scope dot launch. It's to launch a coroutine scope in which you can call suspended functions and do things in a structured way using structured concurrency that comes with coroutines. So what we will do is we will add a delay of, let's say, 2 seconds. So we will be in loading state till then. Now assume that as soon as this delay goes off, what we want is we got the result from server. Assume that this is our server or something like that. Let's remove this from here and paste it down there. Now we have the students list from S1 to S8. Now let's emit this particular state with the new data, with a state in which we are not in loading state and we have some data to show to the user. So UI state dot value equals to UI state dot value dot copy. We'll just copy the contents from the previous state, and is it loading, and we'll just change the content that we want to modify. So is loading was true by default. If we see this instantiation here, so it's by default true. We'll set it to false so that loading, now the view is in not loading state, and we also want to pass in students is equals to students. And because there is no error, then it's simple that no error was sent and it will be always null. So this is like an API got called. You added a delay of 2 seconds. We inflated the dummy items into a list, and then we emitted the UI state with that particular data with loading state as false. Now when it comes to consuming part, let's consume it as well. Now into this particular content view, let's do one more thing. Like, it doesn't look that good here, so I'll add a scaffold so that we have a toolbar as well. So if you go to the it should have a top bar. Okay, so we have a top bar, top app bar, text, let's say student list. Okay, let me do one thing. It's not like that, it should be like this. And let's go to top bar and see what sort of argument it expects out of us. Content is row scope, and okay, we should be able to do this and just add text here, and I guess it requires to be passed in lambda instead of brackets. So this needs to go inside this particular top bar scope, in which it expects top bar from us, and we added the top bar with student list. Now that we have our top bar in place, let's run and see like how it looks. And we just should see a top bar with a title. It shows student list. That's it. Okay, it ran on my mobile. Let me connect it to Pixel 5 simulator. So now we just have our top bar in place. Now let's have view state is equals to view model dot consumer state dot collect as state. Now whenever that thing changes, it will automatically notify the changes into view state variable as well. And let's do one thing. Let's create a box. So box is something like a stack. Your views are added on top of each other on z-axis. They are not like horizontal or vertical. It's rather than it's on z index, and the view will be stacked on top of each other. Now let's just do one more thing. Let's make a loading indicator composable. And it will be a loading indicator. This will be a box which will be having a modifier as modifier dot fill max size dot pointer input as blank, because we don't want to allow user to interact. Okay, let me just remove it. We'll not have that case in this particular example. And let's say horizontal arrangement is, so box has content alignment, and row and column has vertical arrangement and horizontal arrangement. Now let's say content alignment is alignment dot center, so all the content will be in center, and we'll have a circular progress indicator. So this will be our loading indicator. Now let's say that our state when, okay, not let's not have a when statement here. Let's just have a lazy column, and if our view state dot value is loading, then we'll have a loading indicator. Also add this modifier here, which will allow our box to fit the available size. Now let's do one thing. Let's run it and see if we can see a loading indicator, and then it goes off after 2 seconds. Yeah, it goes after 2 seconds, because that's how we have defined our view model to do things. Let's close all these up. Let's make it private as well. Now let's do one thing. We'll inflate the student ID card as we were earlier doing. So we'll have items, and what we want to do with items is that view state dot value dot students, and we'll also have a key to uniquely identify those items. Key will be like item, then item dot id. Sometimes I just don't get why it doesn't work the way I expect it to work. Sometimes because they are like conflicting imports. Let me just do one thing. I need to import the one that works, and this is the items that I want to inflate basically, and this should have value dot students and key equals to items item and item dot id, and we'll have the content scope. So the item scope is there. Now we'll inflate a student ID card with student and pass the student here. Now let's run it. Now we see that, let me just run it again. We see that loading indicator comes, then we see all the list items that we want to have. Now assume that I want to allow a user to delete a certain item. Let's also add the divider here so that we have a clean bifurcation between all the items. Now we have all the cards. Now in this card, what we want to do is we have a column. Let's add an icon as well, or icon button maybe, and on click we will pass a function that can be called from here, and on remove clicked, which is unit, which is a function. So you can just call it on click, on remove clicked, and what we want is we also want to specify which student got removed. So we'll pass the student here, and on remove click we'll pass the student, and we'll have an icons dot fill dot delete, interesting. Let me just check. I guess the correct is icon only, and we can just I'm not sure what should I be doing in. It's an image vector and it should come as is. It's an image vector. Content description will be null. Or maybe just add remove dollar to make it like accessible name. So now we should be having an icon button. On the click of that particular button, we can invoke the remove item thing. On remove click, we'll have Okay, now we want to emit a function in which it will have, let's say, vModel dot handle view event, and that view event will be dot remove item. Let's add remove item here and pass the student that we received from the callback or the method call, like high order function. So now we passed in a student here to inflate the card, and we also, whenever the button was tapped, we also got which student to remove from the list. Now as soon as, let's just run it and see like how it looks first. So we have the delete icon as well. So do one more thing. Let's do one more thing. In this row, let's make vertical alignment as center vertically, so that our items are centered vertically. Now we have the delete as and center. Also, let's add a spacer, and maybe just fill max size, max width maybe. So in Jetpack Compose, we earlier, in very early versions of Jetpack Compose, we used to have Flutter kind of expanded widget, which used to expand into the available space. And now in Compose we don't have that. We might have to just add a weight one off. Now it's sorted. Now we have the defined the required layout. Let's go ahead and do one thing. Let's handle our actions on the view events. Now it's a remove item action. Now let's get the hang of current state, which is UI state dot value. Let's get all the list of items that we already had. List of items equals to current state dot students. Now items, let's do items dot remove. Let's convert it to mutable list, then remove and remove the item that we received from the view event dot student. And let's do it in a different way. Dot apply dot to mutable list dot remove, then again convert it to list dot to list, or maybe just do to mutable list first, then apply remove, then convert it to a non-mutable list, and now we have the items in which we don't have the particular item that user tapped upon. Now let's emit the state. UI state dot value is equals to UI state dot value dot copy. So is loading is already false. We just have to update the students, and that will be items. Now as soon as this state gets emitted, it will be redelivered to the Compose UI or the screen that we are handling at, and it will just remove that particular item from the list. Let's run it and see. Like there are like other optimizations that we need to make when working with lazy list or lazy column, that our list should be like, it works fine when the data type is primitive, but when it comes to a list, these that particular data structure is not marked as stable or immutable. We will have to wrap it around another data class which handles that. So we will be talking about that in a different video. So in this particular video, let's assume that it works as fine. It works as it works fine always, and let's run it. Now if I do tap on this, now it gets removed. 5 it gets removed, 4 removed, 3 removed, 2 removed. Now I also wanted to have some sort of an animation. Let's say that in recycler view we used to have that notify item changed index or notify dataset changed at index, based on which it used to do some sort of animation. Let's say in LazyColumn we want to do the same thing. We can do it via modifier is equals to dot animate. Okay, it's not animate, then maybe it's in a different what do I call it? I sure somewhere read that we have a way to have that animation, but it could be in a different version of Jetpack Compose maybe. It was about item replace something, placement or something. Animate item placement. Okay, let's do a quick search on Google and let's see in which Compose version it is available. So we have an animated item placement. Okay, let's do one thing. It should be into the scope itself. So it should go to this particular student card basically, and at student card we should also have a modifier which will have just a default value, and this modifier will be applied to this particular card. So the property of this particular thing is that it's available in as a modifier, but it should have some sort of it should be in a lazy scope. So it does not belong to LazyColumn. It belongs to items that are inside the LazyColumn. So let's add it here. Modifier is equals to modifier dot okay. So it's not available in the current version of Jetpack Compose that I'm using in, I guess. Let's see on which version I am. It's 1.1.0 alpha. So let's try to update our Compose UI version to 1.30 alpha, I guess. It's 1.1.0 and we have 1.3.0 alpha or beta. Let's do and let's resync it, and maybe we'll also have to update our Kotlin version as well. And meanwhile it does that, let's just remove it for a while so that we can do other things. Now let's let it run. Let's go to student view model and implement our add item as well. So in add item we just don't want to do anything very special. We just want to copy, paste, and instead of remove we'll add, and we'll emit the new state. It's that simple. So now both the states both the actions are being handled properly. Let me just pause the video here until okay, now it's done. So let's just go and check if we can get that particular modifier. So what I was doing here, okay, let me remove this box. should not tell me. Scaffold should have a content which is like a padding values. Why it's that? Hmm. And padding values is just like giving a padding to it. So should we be just removing the scaffold here for a while, because something has changed into it and I'm not sure what's changed. Content is padding values. It's very strange. Hmm. So let's see like what has changed into this particular API. Simple scaffold with top bar. Let's copy it and try to see the example, what they have done, what changes they have made actually. I'm not sure. Simple scaffold with top app bar should be there. So content is being moved to padding values, which should ideally be not the case, but something has changed into the latest version as well. Let's do one thing, let's pass it a padding values. Okay, let's not waste more time here, and let's just remove this particular scaffold here. Just have our, I'll figure it out later on. Let's just remove it for now and add our modifier. That modifier dot animate item placement. Now it has a default value, then why it, okay, we have to opt in the experimental foundation API. We'll opt that in, and maybe just let's opt it at a class level. Let's run it. Let's target Android 33 as well, and resync the project and rerun it. Now it should be an issue with the Kotlin version itself. Let's move to 1.7.10 and 7.10 and sync it. So this is how the incremental changes like gets pushed into an organization, where to get a hang of a particular thing from Compose, you constantly and iteratively have to keep on migrating your code towards the latest available code. And this is the default project that I created it using with Android Studio. That's why it was probably on an older version. And let's run it now. And I guess it should work as expected now. But maybe our that Kotlin compiler extension version should fail. But I have my hopes high. Yeah, it ran. Now let's do delete one of the items. Now you can see that items are properly getting animated and the next item getting shifted up and down based upon the position that they are in. Now let's figure out that scaffold thing and see how we can make it work. We had top app bar. Let's turn it into top app bar. Let's add text, add student list. Okay, let's move it to this. This will be padding values. We might have to just, if we are not using it, we can mark it as underscore. So that content earlier was used to just be a composable, and we can just push in a composable down there, but it's not the case with the latest 1.3.0, and we will have to have these padding values applied to the content, the root content, to offset it from the app and the devices padding. And let's run it again. We do see an, no, we don't see an error, but why it shows an error? Okay, it's showing for this unused parameter. Let's just add it to the root and run it again. You might not see a UI difference. That's how the standard API has changed, so we have to adapt it. Now let's close everything else. So now our content animates as soon as we delete or remove the item. So that's something similar to what we wanted to achieve with this recycler view. Like, there's also a swipe to dismiss kind of a thing, in which we can also do that swipe to delete. I'll do that in a different video because it's already been a lengthy video, I guess. So let's get done with our final piece of puzzle, that is adding an item. And to add an item, what we will have is, we will have a floating action button. Let's do that. And on click, we will just call view model dot add handle event student dot add item, and we'll have to pass a student. So let's not pass the student. Let's go and edit it, make it an object. Sorry, we can change towards a wrong event. Let's make an item as an object, and we'll give this responsibility of creating the instance of the student and adding it into the list to the view model itself. So now we can just call the add item. Now go to the student view list view model, and now let's create a new student. And to keep that dynamic name or something, let's do one more thing with it. Let's do, not like, it could be a name, but I don't want to like do some UI change. Let's just do clock dot okay, let's not do epoch, let's do uuid dot random uuid. And let's do one thing, random dot this random should come from Kotlin math. Dot next int, and let's color, let's take the color as, you can also do one thing, make a private variable of color, private colors. and let's make a list of color dot black, color dot cyan, color dot magenta, color dot blue, and pass random. So it's an extension function on list which will give us a random color, and we'll add a new student. Now there is one more thing. When we talk about key, then this ID is something which is being passed as a key, so we have to make sure that we don't have a repeating ID. For that, let's make let's keep ID as is, because I don't want to spend another random method or an ID generator. Let's make name as unique for now, and because all the names that we have here are unique, and the other ones like generated by random UUID, so they will also be unique, and this should work for us. And let's do this should do it, I guess. Okay, let's run it and see like if we can add items. So we had why okay, did we call okay, so we, instead of following that thing, we inflated an invalid thing there. Let's do icons, and icons dot default dot add new user. So let's run it and we should be fine. Now let's do add. So our item got added to it. Another item got added. Another got added. Another got added. Another got added. Let's do one thing. Let's clean this up a bit and just have one student into it. And we'll see if adding like have an animated effect onto it. So it's not like an animation, but if we change an index and add it to someplace else, we might get that effect. Now let's do one thing. Let's revert this change, run it again. So now we have the basic bare bones setup for deletion and insertion. So this is how we delete the item from the list. This is how we add items into the list. And that's pretty much for this video. In the next video, we'll talk more about swipe to dismiss and how we can implement pagination into LazyColumn and how to get what sort of index is visible to the user, and based upon that, if we are at the last or not, should we perform the pagination or not. So that will be for the next video.